This is Dubious Code, and this is Project Euler number 8. So here I have a 1,000 digit number. This is a fun one because it's a string-based one, I think. Greatest product are 9989. If I multiply 4 digits together, the greatest product is this 5800. That's a 4 digits, and they want the 13 adjacent digits. So for instance, the first 4 digits would be 7 times 3 times 1 times 6. So we want the first 13 digits that give the greatest product. So go ahead and input this number just as a 1,000 character string. Let's go for it. So product equals 1. We'll start with 1. Okay, my first thought is to do this. Step through number by number, or start with the first n numbers. So this would be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Multiply them, and then divide. I have a moving window where I divide by the 7 and multiply by the 0 as I go. But the issue with that is that I can't divide by 0 when I come out. So I guess the solution there is if I'm going to divide by 0, I have to redo the multiplication. I think that moving window saves me from, just multiplying and doing 13. I would do 2 operations instead of 13 each time. I mean, the other choice is to do 13 operations times 1,000, which isn't that bad. It's not ideal, but it's probably the easiest to code. So, I don't think it's that bad. Let's just go forward and see what happens. Product equals 1. So for I in range, zero to length input minus num adjacent. So this is 4. Then we aren't going to go to the last one. We'll make that's the start. That gives 1, 4, I in range 0 to I in range num adjacent. Okay, so digit equals input. This is going to be start plus I colon start plus I. And we'll turn that into an integer. This is a string, we'll turn it into an integer. Main product equals times equals digit. Okay. So I believe this will, let's just go up to the first 10 digits. We'll say we'll pretend it's length 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Input equals that. So we think that the answer is going to be 7 times 3 times 1 times 6, or maybe probably 765. So let's see what numbers get printed out. So print digit dash n. That's product, and we need to keep the maximum. Max product equals 0. If product greater than max product okay. So will we have an error here because we expect the last digit here printed 3? Yeah, let's just run it. So this is Euler 8. Pi Euler 8 dot pi. Or start and range. We don't need that 0. We're ordering comma anyway. And we're missing a colon, semicolon, no, colon, missing a colon. Invalid literal end for base 10. Well, let's just see if we're getting what digits we're getting. That's the first thing. I'm not sure I'm doing that right. So let's see what digits we're getting. All right, so. Oh, I know what I'm doing wrong. Let's see, I think I need to get the global input. Global input. See if I can pull in the... Nope. Am I getting the input? Print. Input. All right, so I'm getting the input. But I'm not extracting... Start. Now that's another one I'm having a little difficulty with. That's okay. Digit. Let's see what my string is. I'm trying to substring it. 0, 0, digit. Oh. Because it's the length of that. So it needs to go +1. Because the slice is wrong. There we go. So what's my number? It's 7316, ends in 7653. So I expect my last couple here to be 7653. Okay, so I'm missing that. +1, I believe. 7653, excellent. I'm adjacent. All right, let's do the product. I'll put this back to an integer. All right, almost getting there. Why am I printing out all these blanks? That is what? Don't need that anymore. Almost getting there. That's 630. That's not the real answer. That's not even the test answer. So we believe the answer is 5832 for the long number. 5832 for the long number. That's the test answer. And now let's give it up to 13. So I don't love doing all this recomputation, but it's only 13 times 1,000. So it's not squared. Well, I mean, I guess it's squared, but it should still be reasonably fast. Yeah. So this is what we think the answer is. but I got logged out again. So I'm going to log back in. On the other screen. Okay. 10681, and let's check. Yay! All right, well, that was a pretty simple one. Dubious codes, Project Euler number 8 in Python. Thanks for watching.